Hello there. Find the equation of the line that passes through the point -2, 2 and is perpendicular to the line y is equal to -4/5x and 3/5. We can read off the gradient of this line, and we'll call that m1, that's equal to -4/5. And because we're looking for the equation of a line that is perpendicular to this line, we can work out the gradient of that line by using the perpendicularity condition, which is that m1 times m2 must be equal to -1. So we can find that m1, we know what m1 is, but m2 we can write as -1/m1, which is -1/-4/5, which gives us 5/4. So we know the gradient of, let's write that, m2 is 5/4, and that's because m1 times m2 must be equal to -1. Now we could go ahead and use this equation. Y minus y1 is equal to m into x minus x1. Using these two coordinates, we can find the equation of this line that is perpendicular. We know the gradient m, so it's y minus the y value here, which is 2, is equal to 5/4 brackets x minus -2. So this gives us y is equal to 5/4x add 10/4 add 8/4 equal to y is equal to 5/4x add 10/4 add 8/4, which simplifies to give us that y is equal to 5/4x add 18/4. So the equation of the line that passes through -2, 2 and is perpendicular to this line, y is equal to -4/5x and 3/5, is y is equal to 5/4x and 18/4. Sorry, this is not clear. Let me just rewrite this. It's right here, 18/4. That's the equation of the line perpendicular to y is equal to -4x/5 and 3/5. Thanks for watching. I'm Alistair. Bye. Hello. The area of a sector of a circle with diameter 10.23 centimeters is 22.86 centimeters squared. Find the length of the arc of the sector. We know that the area of a sector is 1/2 r square theta. And we also know that the arc, or the length of the arc, of the sector is r theta. We don't have theta, so what we can do is first equate this formula, r squared, 1/2 r squared theta, to the area given, which is 22.86 centimeters squared. And if we manipulate this formula, we can have half r into r theta. And this is equal to 22.86. So we've factorised r theta, and without knowing what theta is, we can go ahead and find what the length of the arc is. We do know the diameter, which is 10.23 centimeters. So we just need to divide by 2. So let's rearrange here. R theta now is equal to 22.86 divided by R over 2, which is the radius. And this is equal to 22.86 divided by 10.23 over 2. And the result is 8.94 centimeters. Thanks for watching. I'm Alistair. Bye for now. Hi. The area of a sector of a circle with diameter 10.5 centimeters is 24.86 centimeters squared. Find the length of the arc of the sector. Well, if we call the area of the sector A, area of sector, this makes it easier for us to create our formula. What we do know is the area of the sector, so A, as a fraction of pi r squared is equal to theta over 2 pi. If you look at my first video published today, you'd see me going through these formulas. And we know the length of the arc in a sector is r theta. So we have the area, we have the diameter, and so if we look at the area of the sector, we know that's 24.86. We're trying to find r theta. So on a sketch, this is it. Let's say this is the area, this is theta, the angle theta, and this is the arc. We're trying to find the length of that arc. So we have this times 2 pi, we cross multiply, is equal to theta pi r squared. But we want r theta, so we need to do a bit of rearrangement here. If we have now that 24.86 times 2 pi over r, that will give us r theta. So if you look at that clearly, we don't want r square theta. I forgot we're actually dividing here by pi also. We just want r theta. And if we cross multiply here, we'll get back to where we started here. Pi r square theta. You got r squared pi theta. Now we can go ahead and cancel here. So the pi's get cancelled. We know the diameter, so the radius is just the diameter divided by 2. So we can write now our formula here is let's write it over here, 24.86 times 2, and this is divided by 10.5 over 2, because we're finding the radius. Given the diameter, we need to find the radius, and this will give us r theta. We do not know what theta is, but we know the product of r and theta will give us the length of the arc that we're trying to find. This is r theta. And this, if you compute this using your calculator, you will get approximately 9.47 centimeters. So that's the length of the arc of a sector, the area of a sector which has 24.86 centimeters squared and a diameter of 10.5 centimeters. So most of this was focused on the two formulas, the two ratios of area of sector to the area of the circle, and theta with respect to 2 pi. Thanks for watching this video. My name is Alistair. I'll see you in the next one. Bye for now. Hello there. In this video we're talking about the area of a sector. And this sector contains an angle theta, radians at the center. So sketch is always useful. So this is our sector here, shaded. Now, the way to look at this is to consider the sector a fraction of the circle. It's obvious here that this shaded area is a fraction of the whole circle. So if we write that as a fraction, we have the area of the sector, let's call it just A, as a fraction of the whole circle, which is pi r squared. So area of the sector over as a fraction of the area of the whole circle. And that equates to theta, which is our angle here, as a fraction of 2 pi, because we know we have 2 pi radians for a circle. Now theta is also in radians. And now if we want to find the area of the sector, we transpose this. The area of the sector is now equal to a half r squared theta. And if we just label this a bit more, we have r, the 2 radii, and this is our half r squared theta. And we have the arc here, let's say that's at x, and this is at y here. This is the arc. Now, for the length of the arc, which we have already, actually we indicated that one for the previous video. So just to summarize here, we've made use of two formulas. The circumference of a circle, 2 pi r, and its area is pi r squared. And we see the area of a sector as a fraction of the whole circle. And so we equate the fraction of the sector with respect to the area, the total area of the circle, to theta, which is an angle, of the complete circle, which is 2 pi radians. Theta is in radians. This is important. And that gives us, let me just spell this out, area of sector. Area of sector is equal to half r squared theta. Thanks for watching this video. My name is Alistair. I'll see you on the next one. Bye for now. Hi, today we'll be talking about mensuration of a circle. That's the measurement of a circle. You should be familiar with the circumference. The formula is 2 pi r, and also the area of a circle, which is equal to pi r squared. With these two formulas, we'll be deriving other formulas which concern the mensuration of a circle. First, we'll start with the length of an arc. So this is a sketch of a circle. There's the center here, and we have two radii. We have the angle subtended at the center is called theta, and we're trying to find the length of this arc here. So the arc subtended by the angle theta. Now an arc, and this is based on the definition of a radian, it's an arc that subtends 1 radian, so 1 radian, so it subtends 1 radian at the center, and its length is r. So it just works out to be, the length of the arc in this case would be 1 times r, which is r. Now that implies that if we have an arc which subtends theta radians instead of 1 radian but theta radians, then the length of the arc is theta times r, which is r theta. It's really a good idea to understand how these formulas are derived, though it might be easy to remember them. It's a good idea to understand how they're derived. And this is the first part, or the first video here, which is just talking about the length of an arc. So this is r theta, the length of that arc. Now the word subtend just means this is the angle formed by these two radii here, acting from the same point, obviously, in the center. So that angle formed by the two radii is what's described as subtended, theta subtended from the center. That's it. I'll see you in the next video. Bye for now.